Hello everyone, today we're looking at Unit 2, Lesson 8, Verifying Geometric Properties. So today we're going to use what we've learned in this unit in terms of medians, in terms of perpendicular lines, in terms of bisectors, to prove some piece of information that's being asked of in an example. So we'll get started right away. So it says for triangle JKL with the following vertices, prove or disprove that the median from J is perpendicular to side KL. So let's first draw this and then try to figure out what's being asked of us. So we'll first start by drawing this, just a rough sketch again. Okay, so vertex J is at -7, 1. K is at 6 and 2. And L is at 4, -6. And we'll go ahead and connect those dots. Okay, it says prove or disprove that the median from J, so from here, is perpendicular to side KL. So they're saying we have to prove that if we were to draw a median, remember a median cuts the line it's meeting in half, and they want us to prove that it's also perpendicular. So we have to think about what do we know here. So if it's a median, we have to first show that it's going to cut the line it's meeting in half. So prove the median cuts KL in half. So how do we prove it's cutting it in half? We're going to find the midpoint. So find the midpoint of KL. Okay, that's for, we gotta figure out what that median is first. And then we have to determine, is that median going to be perpendicular to KL? So I'll write that in a different color. So perpendicular to side KL, we're going to need to, it's a question. So is J, and we're giving this a point here. So is this median we drew, let's call it JM, perpendicular to KL? So we're going to have to take a look at both lines' slopes to determine if that is true. Okay, so once we have our M, we can find the slope of JM, and we can already find the slope of KL because we have 2 points on that line. But let's start with finding that median point that will help us to then eventually determine if it's perpendicular or not. So step 1 is we're going to find midpoint of KL. So my midpoint formula, we're just going to take the average of our x's and the average of our y's. So my x's are 6 and 4 divided by 2, and my y's are 2 and -6 divided by 2. So 6 plus 4 is 10, divided by 2 is 5, and 2 plus -6 is a -4 divided by 2, so that's a -2. So that's my midpoint, right? So let's label M as 5, -2. Okay, step 2 is we need to work on determining our slopes and then see if they are negative reciprocals of each other. So doesn't matter which one we start with, we'll find the slope of that median line since we have 2 points. So we'll find the slope of JM. So slope is going to be the difference between my y values over the difference of my x values. So my y values, we have -2 minus 1, and my x values for J and M, we have 5 minus a negative 7. Okay, so negative 2 minus 1 is a negative 3. And 5 minus a minus is going to change that to a plus. So it'll be 12. And then we can reduce that to a negative 1/4. So step 3, we now need to figure out, okay, if my slope of JM is a negative 1/4, what's my slope of KL? All right, and we have to, when we're doing this, we have to think about, is this, the slope of KL, going to be a negative reciprocal of the slope for JM? Okay, because if it is, then we know that they're perpendicular to each other, so we've proved what's being asked of us in the question. So let's go ahead and find the slope of KL. So if I take the change in my y values, we'll say negative 6 minus 2, divided by our x values, the difference, so 4 minus 6. Negative 6 minus 2 is a negative 8, and 4 minus 6 is a negative 2, so m is equal to 4. So if we compare this slope, which is 4, to my slope up here, which is a negative 1/4, we can say since the slopes are in fact negative reciprocals, we can conclude, therefore, we have proved what's being asked of us. So we have proved the median is perpendicular to that side it meets, which is KL. So perpendicular to line KL. Okay, so we've, like I said, we've used some of the different formulas we've learned in this unit or in previous units, right? We've used the whole idea that midpoint, right? We know the midpoint is going to cut a line in half. Then we had to go on and figure out the slope of two different lines and use what we know about them being perpendicular, right, to show that they are in fact negative reciprocals of each other. So lots of key things we've learned here that we're tying all together. Okay, let's try one more. Okay, our next example says a rectangle is defined by the vertices J, K, and L. We're going to show that the diagonals bisect each other. So think about that. We're going to show, how are we going to show that the diagonals bisect each other? If they bisect each other, we should be thinking about our midpoint, right? But what are we going to do with that midpoint? Let's draw it first, and then we'll talk about in detail what we can do with that. Okay, so point J is at 10, 0. Point K is at negative 8 and positive 6. Point L is at negative 12, negative 6. Oops. And then point M is at 6, negative 12. So we'll connect those lines, and it's okay that if you end up drawing something that looks not exactly like a rectangle, I'm going to actually just move this K up a little bit so that it looks a little bit more rectangular, because this is just a rough sketch, and if we put it on a grid, we would hopefully see that it does look rectangular in length. Mine was looking more like a trapezoid, so we'll just connect those dots like that. So we have J, K, L, M to make up our triangle. So we know we're going to have to do something with our midpoint. It's asking us to prove that the diagonals, So my diagonal would be cutting from one corner or one vertex to the next. So they're asking us to prove that this point right here, which is where they bisect each other, right? It's going to show that this side and this side are the same, and then this side and this side are the same, okay? So we're basically needing to find their midpoint. If we find their midpoint and the midpoints are the same, then that means that's a point that falls on both line JL and line KM, right? So if it falls on both those lines, then we can also then assume that it's where they intersect each other because they only cross in one spot. So if they happen to cross in a point that's the same, then we can therefore conclude that that is in fact their point of intersection. And if that point of intersection is the same as both midpoints, then that shows the diagonals bisect each other. So let's just try to summarize that. So we're going to prove the midpoints, or the midpoint of KM and JL are the same. If this is so if so, this will also be the point of intersection, or where they cross. Okay. So we're going to basically find the midpoint for each of those diagonals and then compare them to each other. So let's go ahead and start by finding the midpoint of KM. And that's just going to be the average of my x's and the average of my y's. So my x's are -8 and 6, and my y's are 6 and -12. So -8 plus 6 is a -2. -2 divided by 2 is a -1. And then 6 plus a -12 is a -6. -6 divided by 2 is a -3. Okay, so there's our midpoint for KM. We then need to find the midpoint of JL. So again, we'll just take the average of our x's for JL. So that'll be -12 plus 10 and -6 plus 0. So -12 plus 10 is a -2, divided by 2 is a -1, and -6 plus 0 is -6, divided by 2 is a -3. So if our midpoints are the same, okay, that shows that that's that point of intersection where they cross each other. So we can then conclude that these lines, so the diagonals, KM and JL, bisect each other, meaning they cut each other in half. Okay, that is all for your notes for today.